How does quantum decoherence relate to the observer effect in physics? Have you ever wondered how simply observing something can change its behavior? This curious phenomenon is at the heart of quantum mechanics, where the observer effect and quantum decoherence come into play. So, how do these two concepts connect? Let's break it down. The observer effect refers to the idea that measuring or observing a quantum system disturbs it. In quantum mechanics, this means that when we measure a particle, we change its state. For instance, a particle that exists in multiple states at once collapses into a single state when we observe it. This is a fundamental aspect of how quantum systems behave. Now, quantum decoherence takes this a step further. It explains how quantum systems lose their strange superpositions, those moments when particles can be in multiple states simultaneously. Decoherence happens when quantum systems interact with their environment. This interaction causes the delicate quantum states to become entangled with countless environmental factors. As a result, the quantum superpositions become hidden, and the system starts behaving like the classical objects we see every day. What is fascinating is that decoherence occurs naturally and continuously, even without a conscious observer. The environment acts like a giant measuring device, constantly interacting with the quantum system. This means that the observer effect can be seen as a special case of decoherence, where the measurement apparatus is part of the environment that causes the loss of quantum coherence. In the realm of strange and quirky quantum experiments, decoherence helps explain why we do not see large objects, like cats or chairs, in superpositions of states. Even though their microscopic components follow quantum rules, decoherence ensures that they behave classically. Take the famous double slit experiment, for example. When detectors are placed to observe which slit a particle goes through, the interference pattern changes. This happens because the detector's interaction with the particle causes decoherence, destroying the interference pattern we expect from quantum behavior. So, in essence, quantum decoherence acts as the bridge between the quantum world of probabilities and the classical world of definite outcomes. The observer effect illustrates how measuring or observing a system changes its state. Decoherence reveals that this change is not just a mysterious act of observation, but a natural consequence of environmental interaction. This connection shows us that, in quantum physics, observation is less about conscious awareness and more about unavoidable physical interactions.